Yes. So the direction is part of the graph fx and gx. Okay, so we've got two graphs. They're clearly labelled fx and gx. First question says find g0. We need to appreciate what does that actually mean. Okay, alright, do you know what that means? When you see g bracket 0, what does it mean? What would you normally do if you had the equation?
You put the 0 in the axis.
Good. So you would put the 0 in place of the x, and you would end up with a y value, yes? So all we have to do is to try and look at this visually. So they've drawn us the graph of the results when we've done that for each of the different points. So we're saying that the value of x is 0. So we look on a graph, we're looking at the g function, which is this one. Okay, I'll get rid of that now. Okay, so that's the one we're looking at. We're seeing what is the value of that graph when x is 0. Can you all look at the graph and see if you can tell me what is the value of that graph when x is 0? 3, 2. Yes? So we find 0 on the x-axis and we look at that graph, the g graph, and see what number it is. Okay, that's how we would find that answer. You happy with that? Yeah? So that's 2. Find gf negative 1. It's a composite function. Which of these two functions do we deal with first? F. Okay, so it means we're going to do a similar thing. We're going to stick negative 1 into the function. We'll find out the value of the f function when x is negative 1, first of all. So we're going to look at this. When x is negative 1, we're going to have a look to see what the value of the f function is. You can tell me that more than me and x, surely. More than just me as well. So read just answer one. Go, Casey. Yes. Oh, she says confused but totally correct. So this time we're looking at negative 1, which is around here. Okay, this is negative 1. It's not labelled, but you know that. Here we go. The value of 8. Okay, that's our starting point because that was just f of negative 1. So now what we need to do is to find g of 8 because that's how it works, isn't it? We find the value of the first bit and then we stick that answer into the second function. So now we're finding g of 8. Can we see what g8 is? Negative 2. So again, we're finding 8 on the x-axis, reading down, negative 2. So whilst we haven't really done many of those, if any, have you understand how they work out? Yes? Not sure, yes? Oh, should say. Boring, we've done a few of these. Okay, what are our values missing? I think everyone gets these right.
4.25 and 3.5.
4.35 today? 2.5. And
16.5.
5, 0.
Yeah,
What's that? Okay, so good. Yeah, and we plot that. Oh, what is it like? I can't someone plot it. It kind of looks like this, doesn't it?
Yeah.
Oh no, it's not at all. First one. Oh, really bad. You get the idea. Okay, that's secretly your graph. It was all plotted nicely. I remember that. So it says use your graph to find estimates. Estimates. Okay, that means it indicates it's more than 1. In the interval of the solutions of this graph is equal to 14. So, remember we have done stuff like this. This is the graph they were talking about. But they've said that that graph has to equal 14. So what are you going to do? Someone else going to do? Emma's answered one already. Oh, DNA has actually answered one. I keep trying to roll.
I did that. You draw a line.
Yeah.
Your y equals 14 and then you see what.
You totally do. Let's change that a little bit. So you find 14 on this y-axis. So that's probably about there. You draw a horizontal line, trisbians, and then you read off those two values. Okay? So the key here is that I know lots of people gave just one answer, but the clue is in the question. Give your estimates. Plural. Okay, so there are two. Okay, x equals 1 is one solution of the equation x squared plus 2 over x equals mx.
Wait, so what were the answers?
Oh, I don't know. Okay, so everybody knows how to do this one. The answer's 3. And then I'm shouting at me.
Right. Yeah, I got it. You still keep the one.
Alright, okay, it says, draw a suitable line on your graph to find an estimate for the second positive solution of the equation blah, 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 equals mx for the value found in part D1. Dig your estimate correct to one decimal place. Oh, now it gets quiet. So if we're drawing a suitable straight line on the graph, we want our graph to equal mx. You found that the value of m was 3. Okay, if you found it was something different, you're still using your value, so you will get marks anyway. Right, so it doesn't matter what value you got here, even if you got it wrong, right, if you didn't, you are drawing what you found here. Now, you said that it was 3x. So we're drawing a line that represents 3x. So we have to think about this. Y equals 3x. What would that look like? It's in a good format. Y equals 3x. You know? And where do we start?
Oh, well, you write the gradient. Sorry.
Yeah. So because there's a secret. Oh, that's awesome. Because there's a secret plus 0. Yeah, we all have it understanding this. As Lena said, we would imagine that the gradient is 3 over 1. It told us it was a straight line, so when you see the phrase straight line, you should be thinking y equals mx plus c. So we start at 0, we go up 3 across 1. So we start at 0, we go up 3 across 1. Note, this is my 1. Okay, so you have to go with your, with the actual scale. Oh my gosh, I'm struggling there. With the scale of the graph. So up 3 across 1. So it's probably about there. Yeah, mine's obviously dodgy. So you draw. Oh.
Very Dutch.
You're drawing a line, a straight one with a ruler, not having a big kink in it. And you should have found that one of your line goes through at 1, or one of it meets it at 1, the other one will meet it somewhere else. It should have been approximately 2.7. Again, it's from your graph. So if you had got the wrong value for the initial one, then you would have got that wrong. Now, whilst subbing in the value works for that other one, for this question here, you also had an option to recognize that this is just an mx. We know it's a straight line. Okay, we know that the gradient, the y-intercept is 0. And we know it goes through the value of, we know when x is 1. No, shut up, I think it was.
Wait, what? No, because we know that that's...
So so what you do is you find when x is 1, find the point on the line, and then join this up to here, and then you can find the gradient of it. Does that work?
No,
I'm going back to this one if you go. No, shut up.
Wait, no.
No, wait,
Oh,
stop.
answer x equals 1.
I told you that. Approximately 2.7.
How'd you get 2.7?
Well, where that line,
Oh, yeah.
that line hits the graph again, 2.7 here. See,
Okay.
this line here we just drew,
Yeah.
it hits here.
No, it hits you somewhere else.
No, the blue, the pencil one.
Yeah, I hit one.
Yeah, one. Well, it told you one is one of the solutions, Angel, and they want the other one.
Okay.
Don't get angry. See?
Oh.
There.
Oh, wait.
Okay, so here's another one. What are the numbers?
2.75.
2.7.
3.75. 3 and then 2.75.
Oh, 3.
3.
Okay. So it looks kind of like this. Oh, here we go. Oh. There. No, oh no, oh no, no. Well, you plotted it. You're very good at plotting. Sorry, I'm not stressed about that. Okay, what does it say here? Use your graph, again, use your graph to find estimates for the solution of the equation. Oh yeah. This equals 7. Now, this is where we have to say, well, hang on a minute. That's not the same as this, is it?
Oh, it's not?
So they have x plus 9 over x equals 7. But look, the graph we just drew was a half of this. Okay? So that means that we're not going to draw a line horizontally at 7, is it? Are we? We're going to remember that we've got a half in front of it. So whatever you do to one side, you do to the other.
But there's a half. There's a top one as well.
Yeah, that is that graph. That's what I'm talking about.
Oh, okay. Good job.
Yeah, because that's the graph we've just drawn. So it says use your graph. So we have to compare our graph that we drew, which is this one, to what they're asking us. And so we need to recognize that our graph was a half in front of it, so we're going to put a half in front of this number too.
Oh, I see.
So it means that we're not going to draw a line across 7, we're actually going to draw it across at 3.5. Okay, and I'm going to see mine doesn't hit it, but yours does. Okay, so you draw a horizontal line at 3.5, and it should be 1.7 and 5.3.
Yeah.
So it should be 1.7 and 5.3. So obviously mine's rubbish, so can't help. Random. All right, okay. So here we have a graph of sine x. They told you it. They've asked you to sketch on this graph the graph of sine x take away 2. This is the transformations of functions topic. So we need to remember what effect does having that take away 2 on the end do to any graph. So this is our original function. What does it do to any graph? Casey?
It shifts down.
It shifts the whole graph down 2 units. Originally, I went through the point 0, 0 here. So where am I going to go through? -2. Yes? Here, this goes through the point 90 and 1. I'm going to go down 2 units. So I'm going to go down to -1. Here I'm going at 0. I'm going through at -2. Here I'm going through -1. So I'm going to go down to -3. Here it's at 0. So I'm going to go down to -2. Now, that is how I personally would probably sketch this. Okay, so I wouldn't try and do everything all at once. I would find key features of my graph, translate those to where I know they need to go, and then follow the pattern of the function. So I would then join those points up. So if any of you are sitting in there panicking, stressing, going, oh Jesus, mine doesn't look like it, try that method and that may help. Okay? Oh, try and get this done. Oh, shush now. Right, so here's a function. We don't know what the function is. We need to sketch of y equals x of x minus 3. This time a number is inside the brackets. it's inside the bracket, what happens to the graph? Lots of people got this right. It shifts horizontally. In which direction are we going to go when it's take, subtract 3, Jamie? To the right. So, again, I'm going to take key features of my graph and just shift them across 3 units. So here I've got the coordinate -1, -1. So I'm going to go across 3 units, 1, 2, 3. So it's going to be here. Here is the point. I'm going to go across 3 units, 1, 2, 3. Is 1, 2, 3. And then I'm just going to scrooge. You'll extend it up. Yes? Happy with that? And then the last one, the big 2 in front, what does that do? No, this wasn't done as essentially it stretches it up. Okay? Now, what happens is that you need to make sure that you're aware of what's going on here. So your original function is being multiplied by 2. Okay, so here I have to point 1, -1. So I'm multiplying this number by 2. So where is it now going to be? It's going to be at -2, isn't it? Because I've multiplied that value by 2. So I was going through the coordinate 1, -1. I'm now going to go through the coordinate 1, -2, because I've multiplied it by 2. Yes? This is the coordinate 0, 0. I'm multiplying my y value by 2. What's that multiplied by 2? So 0, yes? This is the coordinate 2, 0. Again, I'm multiplying my y value by 2. It's still 0. If you want to get even more fancy pants, this one here is -1, 3. So I'm multiplying my y value by 2. So where's it going to go up to?
3.
Multiplying it by 2. So it's going to go up to 6. And same with this one here. Okay. So I'm now going to join up this point, this point, this point, and this point. Oh, and yeah, that's it. Yeah. So, on that one. Oops. Oh, I didn't get down, you silly lady. Sorry, not that bit of it. Okay, so the y value has been multiplied by 2. That's what stretched it forward as it did. Okay?